So with that, the question again is, what is zero trust? So zero trust basically is, the fundamental concept that it kind of professes is that don't trust, but still verify, right? Don't trust that authentication, don't trust that user, don't trust that machine, but still perform a verification that that entity, the user, machine, or whatever, is authorized to do whatever action it wants to take, right? So I think that's the fundamental message it kind of sort of fundamentally came out of. And basically what it kind of sort of boils down to is that like IT asset or user cannot be trusted. All user and machine actions must actually be authenticated and authorized, right? And that needs to happen on a continuous basis. Obviously, all network traffic must be encrypted, and we do that in the industry quite a bit. We're doing a good job of it. Also, any access that is provided to a user or to a machine needs to be provided on a basis of least privilege, right? And then that least privilege access needs to be continuously assessed to make sure that the least privilege is maintained. Otherwise, there is always configurational drift, and obviously people accumulate access, machines accumulate access, and that needs to be checked. And the other thing is that for zero trust is that we do need to have a dynamic IT asset inventory, because if we don't really know in our ecosystems what's implemented, what users, what machines, what systems, what virtual machines, what containers, what applications, what COTS, what IaaS, what PaaS. I mean, as you can see, it's a large ecosystem that we have. And if you don't know what we have, half the battle is already lost, right? So we do need that. So the zero trust professes that you need to have a handle on that, and that's generally done through a CMDB. So I think that's at the high level what zero trust is. And then, we'll talk a little bit more later. The pitfalls, obviously, with this is that it is complex. It leads to complexity, as you can see. If we start implementing security controls at the various security domains, which we'll talk about, it can obviously lead to complexity, which leads to skill set scarcity, because sometimes there aren't people that can operate at the various security control level, right? There are network people only know network, applications people only know applications, but if you need somebody or or people that can operate across the board for the various security controls of zero trust, sometimes you may not have that capability or skill set. There's also, it can lead to performance issues. If you start doing end-to-end encryption, if every action has to be authenticated and authorized, right, and various other things that we can talk about, then it can lead to performance issues, and there are ways of how to actually get around that. But that is a pitfall, and I think because of all these various pitfalls, sometimes what I've seen in the industry is that zero trust implementations generally are incomplete. So they start the journey, but they may never finish it. For example, in the network world, sometimes companies will start with the macro segmentation, but they may never get to the micro, right? Because of the macro itself, it overwhelms them sometimes, right? So I think, but the reality is that the industry-wide, we are getting better at doing these implementations. So with that, I'm going to jump on to the next slide. So what I call is, so zero trust is basically done during security domain hardening. Basically, it is security controls at each of these security domains, and we'll talk a little bit more about it as to what they are. So as you can see, that this is not a tool that you can implement and say, okay, we are compliant, we have zero trust, right? You have to go into each of these security domains at the device, in the network, on the data layer, and actually harden them using security controls that actually are very well defined in NIST. So the reality is that a lot of this exists, the guidance exists. The thing is how to actually implement them, and how to implement them in a manner that is relevant to you, for your business, for your entity, right? Because some things may not make sense in a commercial world, which makes sense in the federal world, which I came out of, right? So I think, but this is what when I say zero trust via security domain hardening, is hardening security controls at the level mentioned here, and we'll talk a little bit more about that. Let's begin with the one on the left, right? So zero user and identity security. So we have obviously users, and they have identities, right? So we have to secure how is the identity for a human, which is a user, or a machine is actually provided. Identity is the glue, right, that provides the security for a lot of these ecosystems. And the reality is identity is also a primary glue for zero trust. So before we actually provision identity, provide an identity, provide residency to a user or to a machine on our networks, we got to make sure it's properly proofed. So identity proofing, security controls or workflows need to exist. Concepts like just-in-time access needs to be implemented, or secure tokens, right? And these identities, when they are trying to access something, like if we can secure the way people get access to things, the number of bad things that are happening will reduce, right? If we can just do that securely in a repetitive manner. So similarly, the authentication for a user or for a machine needs to be done in an adaptive manner, what we call adaptive authentication. Also, we should be using strong authenticators, right? So whether it's a device-based authenticator to get into a device, or if it's authentication, the first factor or second factor, or other factors, right? We should be using authenticators that are FIPS validated if possible, or strong authenticators that have NIST accreditation, and obviously using the principle of least privilege, right? So I think that's the user identity security space. As you can see, there are tons of security controls in this area that we could actually implement. The other area is device security. All of us have devices. We have laptops, we have mobile devices, we have systems, we have servers, right? So we have a lot of infrastructure that is out there, especially on the device realm. So we are going to make sure that the physical and the virtual devices are hardened, making sure that, for example, access to those devices, they are tamper resistant. You can't tamper with them and get in, jailbreak a device and get in, right? And any access needs to be done using a biometric authenticator if possible. There are some constructs in the industry known as like MDM, mobile device management or mobile application management, that can actually protect the device and the data that is resident on the device, so that unauthorized access can be prevented. So I think those are some of the things that they are under the hood. There are lots of security controls that are out there in the device security realm, and if we can implement them, then we will move in our journey towards zero trust from a device security domain perspective. The other area, obviously, is network security. We all know about that. So, we got to make sure that our public and our private networks are end-to-end encrypted. We shouldn't have a situation where you offload TLS at your gateway, at the load balancer, or the web browser, at the web server, and then after that you have unencrypted traffic in your backend or in your network, right? That's a big problem. So we shouldn't do that. We've got to make sure that we start implementing macro segmentation, and then follow that up with micro network segmentation. So I think that's in the network security realm. These are some of the things that we should definitely do, and obviously end-to-end encryption is standard. The other thing is that we should obviously do threat monitoring at the network level as well. We all monitor threat at the endpoints, right? But sometimes we do not do it at the network level, and that is definitely important to do. So that's an area that we should talk about. The other area, is in application security realm. So, there are applications everywhere, right? They are in the cloud. They are legacy applications. There are applications, web services. There are, APIs are out there, microservices, SaaS, and so on and so forth. So you got to make sure that as these applications that are operating in our ecosystems or in the ecosystems of our partners even, right? Access to these applications is adaptive. It's secure. The other key point with application security journey towards zero trust is vulnerability management. We got to make sure that the vulnerabilities that may exist in these applications are fixed, and are fixed on a risk-based basis. So, for example, critical vulnerabilities need to be immediately fixed, patched as they are discovered, highs and medians and lows. NIST has published guidelines for that, which is 30, 90, and 180 days. So we should strive to make sure that we fix the vulnerabilities in the application stack. And also make sure that the applications are hardened. For example, any application that is running that is opening ports or protocols or services that are not really required, we should actually shut them down. So I think that's the journey that we should go towards the application security realm. And last thing I'll mention there is that we've got to also start thinking about actively runtime protections, right? Because when we look at application security, sometimes we go do the theoretical analysis of applications, we look for code, we look for vulnerabilities, we try to patch them, but we don't think about which of those vulnerabilities or exploits can be exploited at runtime, because we got to go after those. If we can prevent the runtime exploits, then half of the battle is actually won. Because sometimes the reality in commercial, in corporate America is that we have so many vulnerabilities that we can't really fix them. I mean, that's the reality, right? As a CISO, I've seen this happen all the time, but the vulnerabilities are not being patched on time. So sometimes you got to figure out, okay, if they're not being patched on time, then how do we prioritize them on a risk basis so that we can patch the vulnerabilities that can actually be exploited? So we got to think about that. The other area is infrastructure and workload security. So, all of us are in some kind of a cloud journey. And all of us are using infrastructure as code. We're using platform as code, right? Because nobody is doing these things manually. It's not possible to do that manually on scale, right? So we got to make sure that as we are doing these, that these are indeed hardened. Because if that thing, there's a configurational problem with infrastructure as code, if there's configurational drift, or there is user access issues, right, then your entire infrastructure could be at risk. Similarly, like in IaaS or in PaaS ecosystems or in serverless or containers, we've got to make sure that some of the security controls that I've been talking about are actually applied there. Some of the things like that came out of this summit was certificate management. And the reality is that if you run a large enterprise, it is impossible to manage certificates manually. So you do need automation in that space, and that's where I think like there are lots of interesting vendors that are out there that can provide that capability, Venafi being one of them, right? So definitely that's something we should look at. Then the last domain on this area that I talk about in our Zero Trust journey is data security. We all know that data is fundamental and key to all the, all our applications, all our infrastructure, all the business that we do, right? So we got to make sure that data is encrypted. So whether it's unstructured data, which is the files, and the structured data in our databases, we've got to make sure that it's fully encrypted or hashed in some cases if that's required. We should use authenticators or encryption algorithms that are indeed FIPS validated. The keys, for example, that are used for encrypting data should be stored in an HSM, preferably FIPS validated if possible, right? And similarly, like, apart from the structured and unstructured data, we should also think about data that is at the logical level or at the physical level. And one thing that has been interesting is digital rights management. So digitally controlling who has access to what data is very important, right? And that's how you can actually, like, if you have a proper DRM implemented, then even like, for example, you have better hygiene of data within the enterprise itself. If I have access to some data, but and if accidentally that data is sent to somebody else and they are not authorized to see that data, then they shouldn't be allowed to, right? And that's what DRM can do. And it can do a lot more. It can control like who can read data, who can write data, who can see like forward, for example, an email or a document, right? So I think there are a lot of controls that come in, and all of them can work together to move towards a zero trust journey from a data security perspective. APIs are the gateway to the application world these days, right? Everything is an API, and we've got to make sure that these APIs, as they are exposed, they are protected, right? So there are lots of web services protection capabilities. Obviously, there are secure tokening. There's SAML tokens, there's OAuth, there is JOT tokens, and otherwise that should be used to protect APIs. API keys, for example, have been commonly used. We shouldn't be using them because API keys actually are very long-lived. So if you are using API keys, you've got to make sure that they have HMAC protection on them. So I think those some of the basic constructs of API security need to be applied, and basically they all fall in the area of credential management. The other thing we've got to do in the zero trust journey is to make sure that the APIs are pen tested on a continuous basis. Because if we don't do that, so the thing is, sometimes the threat actors, if they can exfiltrate data or get into your systems from the front door, then why would they go to the additional hassle of hacking in and doing a command and control server and all the other various things that they may do, right? If they can come through the front door by stealing an API key, well, they'll just do that, right? And so I think we've got to make sure that we, as our developers, as they are publishing APIs or microservices, that they are indeed being properly tested, pen tested and otherwise. And last but not the least, what I have done is implemented CNA programs, with certification and accreditation, so that we accredit and certify, the ecosystems that they're going out, right? So I think that works well in a federal apparatus, but it may also do some good in a commercial world as well. The other thing is, email security. So email is a threat vector that we all have, and it actually has been a fundamental threat vector, right? A lot of attacks have come through email, phishing emails, spoofed emails, even spam or other type of attacks, right? So making sure that the email ecosystem is locked down is extremely important towards our journey towards zero trust. We should have protection not only for inbound emails, but also for outbound emails as well. We've got to make sure that phishing, obviously, spam and spoof are all blocked. And the last but not the least is, constructs like DMARC, which is, like protecting the emails when they are outside your ecosystem is very important, right? So like going towards a DMARC, even if you can go to DMARC quarantine, if you know what I'm talking about, then that is actually victory. Not everybody can go to DMARC reject. So I think those are some of the constructs in the email security domain that people should think about, as if you want to protect your emails, if you want to protect your brand. You don't want somebody impersonating your brand and sending an email outside in the ecosystem to another person saying, hey, pay this invoice. And that has happened in the ecosystem where email attacks have been used for fraud. So we've got to obviously make sure that that happens. And so securing the email domain is an important area towards getting towards in journey towards zero trust, right? And last on this side is the OT and IoT security. So we all are running a lot of IoT, and we got to make sure that IoT devices are properly protected. So what I recommend is especially for IoT and even for OT is that they be segmented off the corporate network. They should not be sitting on the corporate network. They should have their own DNS server. They should run their own firewall stack. They should be segmented off on their own VLAN or other networking constructs, so that if there's something were to happen in those in the IoT realm, because the problem is that a lot of the IoT devices are kind of still unmanaged. The ecosystem that they run on, sometimes they have vulnerabilities and the patches are not available. And patching IoT or OT devices has also been pretty difficult. So there are some fundamental network segmentation constructs that are available to make sure that we can protect our IoT and OT systems. So I think that's an area that we should not kind of sort of neglect just because it's IoT. For example, you may have heard that televisions have been hacked and they have actually taken part in DDoS attacks, right? Or other IoT devices have taken part in DDoS attacks because they have been hijacked, right? So I think there are areas that we have to be on the lookout for. The other area is cloud security. We all are in our cloud journeys. We all know that. So we've got to make sure that as we go into the multi-cloud ecosystem, because all of us now at least have maybe 3 or 4 cloud providers, right? And then you add the SaaS on top of that. You add Salesforce. You add various other constructs, and all of a sudden you have an ecosystem that is very diverse, and they don't share identities, right? So they have their own authentication schemes. So making sure that the cloud security realm of the identity is that glue, making the identity and access management paradigm for cloud is uniform and standardized, and that can be done through federation. That is entirely possible. So there are lots of security controls and patterns around that. Similarly, I talked about infrastructure as code and platform as code. We got to secure that. The other thing is that what I have done with a lot of success in cloud security realm is actually publishing security patterns to the development teams and to the cloud infrastructure teams, making sure that, okay, this is how you will actually configure a firewall or a WAF or segment or key management in the various types of clouds that they may be operating in, because sometimes the cloud native services are a little bit different. So we have published those and we have met with a lot of success, reduced the number of configurational issues, or for example, open buckets or public IP addresses, being attached to private VPCs and otherwise. So we have tried to do that, and that has proven to be good. But I think that the cloud security area is a fundamental area in the journey towards zero trust. I did mention physical security here because we forget about that sometimes, because physical security attacks can happen. People can break into data centers or into offices. Like, for example, offices have network closets that are not very well protected. And sometimes they have switches in them. They have sometimes firewalls sitting in them. They have other hardware in them that if somebody can get in and put sniffers in them, they can actually launch an attack with that. So we've got to make sure is that we at the bare minimum implement NAC, which is network access control, so that, and apart from the standard, security guard and the various other things that we all do, we've got to think about, protecting the physical perimeter of our offices, of our data centers, of our various other facilities where people are working from, shared offices. And we also have to protect our utilities. If you remember the Target hack where the attackers came in through a utility, like a HVAC system. So we've got to make sure that we have visibility and protection capabilities implemented for those. Certificate issuance has to be done so in an automated manner, and it has to be done so securely, right? So that whether you are using an internal CA or using an external CA, and the certificate expiration has to be managed, the CRLs that we've been discussed earlier, that has to be done in an automated manner, because certificate-based authentication is key in the machine identity or in the machine security space, right? And there are a few other tokens that it can be used as well. So, and making sure that these certificates or these so-called tokens are stored in a hardware security module that is first validated. Automation is key in that area. And then, like for example, the paradigm that we all have is that we are in this whole cloud-enabled world. We are either have the capability of bringing our own keys into a conversation, whether it's IaaS or SaaS, or we are holding our own keys, right? So I think we got to make sure that in the machine security space, these capabilities are implemented and obviously there. And last and not the least is, like for the machine security space, we've got to make sure that we do have the capability to do breach remediation. A lot of the times, if there is a breach, how do you remediate from that? How do you recover from that, right? If, for example, if the CA itself was compromised, now how are you going to recover from that? Because if the private key is stolen, how are you going to deal with that, right? So you have to make sure that you have dual root CAs, or you have recovery capabilities built into whether it's the domain controllers or other issuing authorities. So that thing has to be thought of in advance. You can't do that at the minute after your domain controller has been breached or stolen or hacked, right? So breach remediation is important, something that has to be thought about. There is a lot of security controls that are available in that space. That's something we can think to and talk to. So with that, I'm going to move away into takeaways as time is coming to an end for this presentation, is that what we have talked about today is that the Zero Trust is a framework, it's a methodology, and it is not a tool. It is not something you can deploy and say that you have Zero Trust, right? It is basically controls, security controls that you all already have, that you know about, that has been published by NIST. You just have to do them in the various security domains. And then you have to do them in a way that matters to you based on your business, based on your risk tolerance, right? So that's what Zero Trust is. It is indeed complex. As you can see, if you start doing some of these, like for example, device security, network security can get extremely complex. So you've got to use a phased step-by-step approach in that journey. I feel that it is really something that is required in this high threat landscape that we all operate in, right? It is a required entity that we should all think towards. We should prioritize which domain we should start our Zero Trust journey with, and then slowly build upon that. And like I have to reiterate that it can be implemented using existing security controls that we know about. We just have to start that journey. And we should, again, use a risk-based and a phased deployment approach. You don't want to try to do all of this in 1 year, in one release, or in one phase. You've got to slowly start in a multi-year, multi-phase journey. And there are lots of interesting partners that you can have, like in the machine identity space, Venafi is a great partner, right? And then a few other areas you can go in the network security space, a lot of great partners there as well. Thank you, everybody. I appreciate it.
Raj, great job, Raj.